Now, our permutations are without repetition. We kind of talked about the with repetition, without repetition, with replacement, without replacement, that sort of stuff before. So your permutations are going to be something that is going to be, for the most part, we can say without repetitions. Okay? Now, the way you want to think of this, I'm going to write it out in words the way we say it. We say that something is like, we've got n objects chosen k at a time. Okay, n objects chosen k at a time, because I'm going to give you some formulas, and there's going to be an n in the formula, there's going to be a k in the formula. Now, we all know that formulas can be written with different variables, so if some other book didn't use an n and a k, that's okay, it's still going to be the same formula. All right, now, underneath here, I want you to also note that this is where order is important. And right now that's not going to make sense, but once we start doing these story problems, it is, okay? Where the order that things arrive in is important. Now, various notation, depending on the book that you are reading, all right, or the Math Excel, or the online assignment, or if you're on some random web page, you could see permutations denoted as a capital P, parentheses, n comma k, with the n and k being lowercase letters. All right, so that's the mathematical notation for you're doing permutations, and you've got n objects that you're choosing k at a time. You could also use a capital P, a set of parentheses with a little n and a little k, the n on top and the k on the bottom. Okay, again, different notation. All means the same thing. All right, then the one that I'm going to use most frequently is going to be the capital P, and then little subscripts. We'll have a subscript N on the left-hand side, subscript K on the right-hand side. So this is the one I think that's in Math Excel. All right, if we get around to doing some stuff on the graphing calculator, this is the one you're going to see. All right, but these are also common. Okay, so if you see them, if you're looking at something on a website and you see one of these others, it's the same thing. Where the n is important because that's your number of objects. Where the k is, that's important because that's how many you're choosing. Choosing k at a time. Choosing k at a time. Okay, now I gotta go to a new piece of paper. The formula you're gonna have to know. Capital P, n k. So this is a formula for permutations. Is n factorial over n minus k factorial. Set of parentheses around that n minus k. All right. This formula gives the number of arrangements of n objects taken k at a time, which we've already said, k at a time, which, I should say in which, the following things are true. So I'm going to list them down here. The n objects are distinct once an object is used, it cannot be repeated. Okay, so there's that without repetition. All right, and order is important. And that's probably the most number one distinction part that you got to remember more than anything else. That's why I put it in all caps. Order is important. So when they present you with a story problem, and you'll see as we start to do this, if the order in which things are being selected makes a difference, then it has to be a permutation. If the order in which the objects are being selected really doesn't matter what order we get them in, then obviously it's not going to be a permutation, it's going to be the other word, which is a combination. Okay, now, To begin with, you're just going to have to do straight permutation problems with no story problem connected to it whatsoever. So they're going to ask you to do problems like, and it may say evaluate, find the answer, find, okay, just a capital P with a 7 and a 3. Okay, so that's nothing more than just a numerical calculation. Plug it in the formula, work it out. Okay, so obviously the K is the 7 is the N and the 3 is the K. So follow this formula. Okay, that's all there is to it. So those are going to be straightforward, simple. So this is my N number, this is my K number. So then I'm going to have a 7 factorial on top. I'm going to do 7 minus 3 on the bottom, 7 minus 3, put a set of parentheses around it with my exclamation point. Okay, now 7 minus 3 we can do in our head is going to be 4. Now 7 factorial over 4 factorial. Now if you are doing this without a calculator, all right, this is the way you're going to approach this. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 all the way down, right? And 4 means 4 times 3 times 2 all the way down. So if you're doing this by hand, you're going to start going down 7 times 6 times 5, but then because my denominator has a 4 factorial in it, I don't want to keep going. I'm going to stop and write the rest of that just as a 4 factorial. Because why? When we have something in the top and we have something in the bottom, we can legally cross it out, right? So 4 factorial and 4 factorial will cross out. And then that makes, I mean, not that it's a lot, but it makes a little less that you would have to type in calculator. So all you got to do 7 times 6 times 5 and you're going to have the overall answer. Okay, so whatever you get when you do 7 times 6 times 5, which I don't know, I think it's 210 if I did my math right. Somebody can check me and make sure it's 210. All right, but some basic computation on can you just evaluate them with no story problem connected to them whatsoever. Okay, all right, so straightforward, pretty simple, because we know what factorials are. All right, now the whole point of this is to be able to connect it to a story problem. All right, so we'll do 2 different story problems that are specifically for permutations before we introduce the combinations. So this problem, as a permutation, you would set it up 365, 3. You're picking 3 birthdays out of 365. 3 different birthdays. This one I did right underneath permutation, so you know it's a permutation. All right, probably on Friday, today's homework, all the permutations will be together, all the combinations will be together, but then on Friday you're going to have them all mixed up and you're going to have to make a choice. Well, is this a permutation or is this a combination? Okay, so just kind of pay attention to the different types of story problems that we list individually today. All right, so then that means what? We've got 365 factorial on the top, 365 minus 3, and then factorial on the bottom. So 365 on top, let's see, that'd be 362 on the bottom. Okay, then only go down as far as you need to so that you can cross out a factorial. So 365 times 364 times 363, and then I'm going to stop with my 362. I'm going to leave it as a factorial so that I can cross them out. This is going to be a really big number, 365 times 364 times 363. So you just multiply those out. I'll go ahead and give you the answer. Somebody multiply it and check, make sure I wrote this number down right. 48,228,180. 48,228,180 ways for 3 people to have different birthdays. So obviously we're not going to ever list that sample set because that wouldn't be possible. Okay, so we're just coming up with how many. We're not going to list that sample set. We're not going to look and see what they are. We're just going to go how many they are. Does that make sense so far? These 2 numbers, for the most part, the bigger one is always on the left, usually. The smaller one is always on the right. I can't really think of a scenario where it's not. And yes, there could be the same number on both of them. Okay, so let's do one where it's the same number on both of them. Let's go back and look at our definition. My objects are distinct because I got 4 different people. They're not the same people, it's 4 different people. Okay, once a person lines up, they can't repeat themselves and line up again. You can't be first in line and third in line. So the order is important because whoever's first in line versus who's second in line versus who's third in line versus who's fourth in line means the order is important. Okay, so when I say order is important, that's what I mean. Okay, it is a permutation. So I've got 4 people and they're lining up in 4 spots. So my permutation is 4, 4. 4 people, 4 spots. Okay, so it's going to be a 4 factorial over a 4 minus a 4 factorial. All right, that's going to give us a 0 factorial on the bottom. What did we say on Monday that 0 factorial was? Yes, 1. Okay, by definition, 0 factorial is 1, so you have to remember that from the other day when we talked. So really, this is just 4 factorial, which is really just 4 times 3 times 2 times 1, which is 24. Now, the way I was doing things on Monday, okay, just as an alternate way to look at this. 4 spots. This is the first person in line. This is the second person in line. This is the third person in line. This is the fourth person in line. If I've got 4 people, I got 4 options that could line up here and be in that first slot. Okay? Now, once that one person is there, how many people are left to go into the second spot? Only 3. Now another person has gone. How many's left out of those 4 people to choose from for the second spot, or the third spot rather? And then how many people's for the last spot? Okay, so now you can do it with a formula, but when it's permutation, that type of method also works as well because you can see that pattern right there. So however your thinking is, the formula works for permutations. All right.